Hello. In this video, we'll talk more about how to use FreeMarker in the context of creating views in a web MVC application. We'll talk about three important things in FreeMarker: interpolation, directives, and built-ins. We already saw interpolation in our previous examples. The syntax is pretty simple, just $braces. And inside, we can reference a model object passed from a controller. Now, let's be more precise about what interpolation does. First, not only we can put a variable inside like this, we can actually put an expression inside. So what's an expression? This is actually one of my favorite questions to ask in a programming class. The answer is that an expression is anything that evaluates to a single value. For example, we could have something like a plus b minus c divided by d times parentheses 1 plus 100 and so on and so forth. So this thing looks kind of complex, but eventually all of this evaluates to a single value. So this whole thing is in fact an expression. So what if we have, for example, something like if x greater than 1, then do something and so on. Now, this is no longer an expression because it doesn't evaluate to a single value. In programming languages, this is called a statement, if statement in particular. So basically, interpolation in FreeMarker does two things. It evaluates the expression inside to produce a value, then it converts the value to a string and combines it with the template text. In the hierarchy of the elements in a programming language, expression is here. An expression can be a single value, or aka a literal, or a single variable, or a number of them combined together with operators. And then from expressions, we can have more complex constructs like statements, functions / methods, classes, packages / modules, and so on. So what literals can we have in a FreeMarker expression? Well, like most languages, we can have strings, numbers, and Boolean values, true and false. Note that numbers and Boolean values pretty much look the same as the Java ones, but strings can be double quoted like this one, or single quoted like this one. In other words, strings are more like HTML strings rather than Java strings, which can only be double quoted. FreeMarker also supports two additional types of literals: sequences, which basically are like arrays and lists in Java, and hashes, which are equivalent of maps in Java. Because we use FreeMarker in an MVC framework, collection data like arrays, lists, and maps usually come from controllers. It's very rare that we need to specify those data directly in a FreeMarker template as literals. Operators in FreeMarker mostly look like Java operators, and most of them like arithmetic operators, plus, minus, multiplication, division, modulars, for example, are basically the same as Java ones, and logical operators like and or negation are also like Java ones. Now, with that being said, some operators do get additional quote-unquote power in FreeMarker. The most commonly used one is the equal comparison operator, which can be used to compare strings in FreeMarker, unlike in Java where we have to use the equals method. And then, for example, there are some additional things like plus can be used to concatenate sequences, and brackets can take not only indexes but also a range to get substring or subsequences and so on. So if you are interested, you can check out the documentation, which is here, to see all the operators and so on. But once again, because we use FreeMarker as a view engine in a MVC framework, most of the processing is done in controllers and service classes. We only use FreeMarker to display some results, so it's quite rare that we need to do any fancy operation in a FreeMarker template. We do need to know about the alternatives to the comparison operators though. Later we'll see FreeMarker directives, which look like special tags. For example, the if directive looks like this. So if a Boolean expression and then the end if. Now, because the less than and the greater than operators use the same characters as the brackets used for the tags. When we write a Boolean expression inside a directive, for example, if directive, if we say if x greater than 1, notice that it can confuse FreeMarker because FreeMarker may interpret this one as a close bracket instead of a greater than operator. Now, in those situations, we can either put this expression in parentheses, but we can also use the alternatives to the comparison operators. For example, here instead of saying using the greater than operator, we can say GT or use this alternative. And this is generally more recommended than using the parentheses. Is considered more elegant. Your preferences may differ, but either way, you should know that there are alternative operators for comparison: less than equal, greater than or equal. Okay, so in addition to literals and operators, expressions can also comprise of variables. We can define variables inside a FreeMarker template using a directive called assign, which is basically like declaring and assigning a value to a variable in Java. But once again, this really doesn't happen that often. It's much more common that the variables are model objects that are passed from controllers, and we can access those objects and their properties in FreeMarker. Now, before we continue with FreeMarker, let's take a quick detour and talk about properties. Because Java doesn't have a specific syntax for properties, the concept sometimes is not covered in regular Java programming. But Java does have properties and they are widely used in web programming, so we do need to know about it. So what are properties? Well, they are something that look like public fields when you use them, but they are accessed via getters and or setters. Let's first take a look at properties in C# and JavaScript. I think it will help us understand properties in Java better. So let's take a look at C# properties first. So this is what a property in C# looks like. Now, C# syntax is actually quite similar to Java. So we have this class here. We have a private field called double, which stores a number of seconds. And then we define a property called hours. And this hours has a getter and setter. And the getter will take the number of seconds divided by 3600 and return it as the hours number, right? And similarly, the setter will take the hours value and then multiply it by 3600. So the syntax is different, but you can kind of see that it's a field, it's a something with a getter and setter, right? And now the interesting thing is how this hours property is accessed. We can access it simply by saying object t dot hours. Notice that this is not a method call, right? We don't say t dot get hours, we simply say t dot hours. So it is as if hours is a public field of the object t, and we are simply assigning a value to that field. But behind the scene, this value is not assigned to this field. It actually gets to the setter, and that value is converted into seconds and then stored here. But the syntax look as if ours is a public field of t. And similarly, when we try to get the value of ours, again, it's not a method call. We don't say get hours. We simply say hours, and behind the scene, the getter of ours is invoked, and it takes the value of the seconds and then return that value divided by 3600. So that's basically what properties are. They look like fields, but they are backed by getters and setters. And we can take a look at one more example, which is the JavaScript example. So this example, for example, shows a JavaScript object with two regular properties, name and surname, and it has another property called assessor property. And this one, again, is basically a getter. It says get full name, and then it returns a combination of the first name and the surname, right? And once again, notice that this is a getter, but when we access this full name property, we don't access it as user.get full name. We simply say full name as if it's a regular property or a public field in Java. And behind the scene, this one gets translated to an invocation of the getter. Now, that's basically the idea. Now, what about properties in Java? Well, Java, unlike C# or JavaScript, doesn't have a specific index syntax like this or this to define properties. Instead, properties are defined implicitly by getters and setters. So take this class as an example. We have a class called user. This one should be lowercase, by the way. And it has two fields, first name, last name. And we have a getter called getFirstName, a getter called getLastName, and we have a third getter called getName, which combines first name and last name. Now, these three getters, in fact, define three properties: first name, last name, and name. So notice the difference between properties and fields. We only have two fields here, but we have three properties, and the name is indeed a property. Because Java properties are implicitly defined by getters and setters, it relies on some naming conventions. In particular, the first letter of a property name should be in lowercase, and that first letter should be capitalized in getter and or setter. And this is why in this example, the property name is lowercase first name, lowercase last name, lowercase name, and in the getter, F, L, and N are all capitalized. That's just the naming convention. And just like everything else in Java, property names are case sensitive, so be careful here when you say, capital F first name, then you will get an error that says no such property because the property name is actually lowercase f. And one more thing about Java property, if there's only a getter but no setter, then it defines a so-called read-only property. Similarly, only a setter defines a write-only property, and if there are both a getter and a setter, it's called a read-write property. Occasionally, you'll see these terms in an error message. For example, if you see an error message that says fail to access property so and so because it's write only, then you should know that you probably forgot to write a getter for that property. Okay, so now let's see an example of accessing property in a FreeMarker template. And we'll reuse our Spring Boot example from last time. And right now, let me run this first. Run as a Java application. And let's open up, where is the browser? It's here. Okay, we have hello John Smith, and that's because we added two attributes, John and Smith, and the template is this one. It says hello, first name and last name, and both are model objects passed from the controller. So before we do anything, let me do this. We can do a customize perspective, and this allows me to customize this toolbar. This toolbar has lots of icons on it by default, and I really don't use all those stuff. So what I typically do is to uncheck the ones that I don't use. I don't use coverage, external tools, and I don't use this. Search, I think is probably useful. Let's keep that. We want to keep the web browser and let's get rid of all of other stuff. Okay, so now it's a lot easier to find where that browser is, and also I can drag this one over here. So next time it's easier to run the application just from here. Okay, so this is what we have, and we want to show an example of some object with property, and so let's get that object first. So I'm going to reuse the guestbook entry code because um, we're going to kind of do guestbook in Spring Boot later. Might as well do this. So I'm going to create a new package called 3020.model, and I'm going to copy this one over here. Okay, so this gives me a new model class to play with, and we already have an ID name message. I'm going to add one more field called date, and I'm going to use this one to demonstrate how to formatting date types later. So I'll add date here, and by default, I'll say date is current date, and let's add a couple of getters and setters. So let's generate the getters and setters for dates. Okay, so far so good. And notice that right now we have four fields: ID, name, message, and date, and we have all these getters and setters, and they basically define properties that have the same name: ID, name, message, and date. Let's add one more. So I'm going to define another getter, and this getter I'll call it get all, and this one simply returns the combination of name and message. So it will say name says message, something like that. Right? So notice that there's no field called all, right? It's just a getter called get all, and it's a combination of name and message. But as we know, this defines a property called all, and lowercase a because of the naming convention. Okay, so now we have this new model object, and let's do something in our index controller. So what I will do is, what do I want to do? What I'll do is this. I'll say let's do a guestbook entries here. Import list, and this one import this. Okay, and I'm going to create a constructor for index controller, and inside this constructor I'll create a couple of entries. I'll say new array list guestbook entry, and say entries at new guest book entry. Tom says hi, and John says hello, something like that. Okay, so now I have a list of 2 entries, and I'm going to pass that one to the view, and just like I pass first name and last name to there. Okay, so let's go to the view, and then let's say entries 0 dot name. Okay, knowing what we know, this is an interpolation, and entries is objects that we pass from the controller, and bracket 0, bracket is an operator, and bracket 0, as we know from our Java language, is accessing the first entry in this list or array. Right? And that should give us a guestbook entry object, and the guestbook entry object has a property called name, so this one should display the name of the first entry, which should be Tom. So let's see, we refresh, and Tom it is. Now if I change this to message, and it says hi, right? And so now we can see that first of all it works, and secondly this is the syntax to use to access a model object and its properties. Now remember that we have defined where is that model object? Model class here. Remember here we defined another property called all, right? It's the combination of name and message. So instead of message, let's say we say all. And it shows Tom says hi. So now we should be fairly convinced that this one indeed is referencing the all property of that entry object is not the syntax is not get or something like that. It's simply dot and then the property name. Now, one more thing I want to show is a property could have its own properties. And if we look at the date property of this object, is a local date type. And if we look at local date, it's this one. And it's a local date class, and we could try just say date here. So that's the property name. And if we say date, it shows 2023 10/07. That's indeed the current date, and that's because whenever we create a new entry, we get the current date. But the interesting part is that because this one is a local date object, and if we look at the local date object, we can see that it has a bunch of getters of its own. For example, it has a get day of year, right? And it has a day of week and get day of month. And we know that getters and setters define properties. So if there's a getter called get capital day of month, then that means it defines a property day of month with lowercase d. And knowing that, we could say date and day of month, for example, because there's a getter and the getter defines a property. And this should show us the day of month. And it indeed shows day of month, which is the 7th. Okay, so this is how we can access objects and access their properties, or their properties are properties in a FreeMarker template using interpolation. Okay, so now we know how to use interpolation in FreeMarker. Let's take a look at directives. So interpolation let us do expressions. But what about more complex constructs like statements and so on? In particular, what if we need to use some control flow statements like if statement, loop statement, and so on? Well, that's where directives come in. They basically let us implement logic like if else and loop in FreeMarker templates. FreeMarker directives look like special tags that instead of using just brackets, it use bracket hash, then closing bracket. And each directive has a name, and some of them have additional parameters. So by and large, they look kind of like special tags. Now, FreeMarker has a whole bunch of directives. This is the directive reference, and you can see all the directives here. Now, for our purpose, though, there are only two directives that are important. The if directive for doing if else stuff, and the list directive, which is for iterating through a collection of data. This is what the if directive looks like. It's bracket hash if and then a Boolean expression. And if this expression evaluates to true, what's inside the tag will be included in the generated document. And this one is one with an else part, but the syntax is pretty easy to understand. And this is what the list directive looks like. It's used to iterate through a collection of data so they can be displayed one by one. For example, here, suppose users is a list of strings, then we can use the list directive to iterate through each user, and for each user output HTML list item. Notice that this syntax is basically like a for loop in Java. And also, although the directive is called list, It actually works on all Java collection classes. If you remember, uh, Java collection classes are the classes that implements the collection interface, and it includes, for example, array list. It also includes other list and sets, um, queues, stacks, and a whole bunch of other things. Basically, if it's a collection in Java, uh, or it's a FreeMarker sequence, then we can use the list directive to iterate through all the items in the collection. Now, the basic usage of the list directive is like this. We say list and then the collection name as item name, and then we use that item name inside in each iteration. There are a few useful variants of the list directive. This one, for example, uses additional sep directive. Sep stands for separator. So this one is useful. I personally think it's quite useful. And this is when we want to do something like this. So suppose we want to display a list of usernames, maybe John, John, comma, Tom, comma, Sue, and so on. So oftentimes we want to display a list of items with a separator, except for the last one, which shouldn't have a separator after that. And this sep directive is intended to do just that. And if we do it things like this way, and if we have 3 users, then it will output the result like this without adding another separator after the last item. And also, we often need to deal with empty lists. For example, in this example here, suppose the users list is empty, then this will not get displayed. However, we will end up with an empty UL tag, and that doesn't look very good. So to avoid that, we could use this variant of list directive, which use a list directive to wrap around items directives. Now, if the user's list is empty, then none of this gets displayed, so we don't end up with empty UL tag. However, if it's not empty, then we have the UL and we have the items directive, which can be used to iterate through each element in the user's list. So that handles the empty list case. And this one is basically like this one, except that it has a else part. So if it's an empty list, we can display something like that, something else. Okay, so now that we know about the directives, let's use the list directives to display the guestbook entries in a table. So instead of doing the entries one by one, we can do all of them all at once. So so what do we do? Well, let's try this one. So we'll say if there are entries, we display them as a list. Otherwise, we say no one has left any comments yet, something like that. Okay, so we get these things here, and we'll have entries, and instead of an ordered list, we'll have a table. We'll say table has border 1, and then we'll have a tr. We'll say, what do we say? We say name, and message, and also date. Okay, and then we use the items directive, and for each item we'll call it an entry, and each item should give us a row, and the first one is entry.name, second column is entry.message, and the third column is entry.date, something like that. And if the entries list is empty, we'll get into the else part, and here we can say no entries yet, something like that. And so this is how it looks, and it looks reasonable. And this is how we can use the list directive to iterate through a collection, and for each item in the collection we do something. In this case we display it as a row. Okay, so moving on, there's one more FreeMarker template language construct we need to know, and it's called built-ins. You can think of built-ins as additional properties or methods of FreeMarker adds to objects, and these properties or methods are accessed using the question mark operator instead of the dot operator. Here are a couple of the examples. For example, suppose animal.name is a string, and then we can say question mark built-in cap first. You can kind of tell cap first would capitalize the first letter of a string, right? And that is what it does. And here is a Boolean expression that evaluates to either true or false, and question mark string is a built-in that convert true or false into either a yes string or no string. So this is what built-ins look like. FreeMarker has lots of built-ins. If you go to the documentation, and you can see the built-in preferences, built-in reference, excuse me, built-in references, and you can see a whole bunch of them. But of course, there are some built-ins that are more useful than others. Size built-in is quite useful because it gives us the number of items in a collection or sequence, and this is used quite often. And there are some string built-ins that are kind of useful too. You have, for example, you have trim, which trims a string of empty spaces. You can check whether a string starts with a certain character or substring using start with, and you can get the length of string so on and so forth. So you can kind of tell by the name that they work in a similar way than as the string methods in Java. And then for me, I think the so-called loop variable built-ins are also quite useful. These are where are they? These ones. Now, the reason is that oftentimes I want to get the index of an iteration in a loop. In Java, if I want to do that, uh, I can simply use a for loop like for int I 0, for example, I less than mm, uh, some collection dot size, for example, and then I can use I inside the loop, and I would be the index in each loop. The thing with FreeMarker is that FreeMarker simply doesn't have a for loop with index. It has a for each loop like this one, right? So this one is equivalent to a for each loop in Java, but there's no index here. So occasionally I would like to know the index inside the loop. To do that, we can use this index built-in. So if we do a loop like this, and the inside I is the item, and if we do I question mark index, that give us the index. So the output of this would be 0A, 1B, 2C for this sequence. So the loop variable built-ins are kind of useful, especially the index one. I tend to use quite often. Last but certainly not least, the built-ins for formatting numbers and date time. These are always useful and always something that we need to do when we display numbers and date times. So here are some examples showing how we can use the string built-in to format numbers. So without built-in, if we just put the number in an interpolation, it just outputs the number itself. If we use the string built-in, we can format the numbers in a number of ways. There are a few predefined ways. For example, currency would format it as a currency. It automatically adds the dollar sign, and it automatically keeps only 2 digits after decimal points because there's no 3/10 of the cent. And if we say percent, then it automatically formats a value as a percentage. It actually times this value by 100. So if we don't want to format it in any predefined way, we can specify our own patterns. This pattern basically says we only want the integer part of the number, and this pattern says we want the number with 2 digits after decimal points. So this is how we can format numbers. Now, formatting Java date in the utility package is a little tricky. The reason is that although the class name is date, it actually contains time as well. So FreeMarker doesn't know whether to treat a data object as a date or as a time or as both date and time. So these three built-ins, date, time, and datetime, basically serve the purpose of telling FreeMarker what the data object represents, and then the string built-in can be used to format the date in a number of ways. Assuming, for example, D is a Java utility date object, then we first need to apply the date built-in to tell FreeMarker that this object represents a date, and then afterwards we can then use the string built-in to format it in different format. So the short format is this one, medium is this one with 3-letter month, long is full month's name, and the full will also include day of the week. So if we want to format it with a pattern, we can also do that. This one will use 2 digits for month, 2 digits for day, 4 digits for year, right? So it will be 10/06/2023 as opposed to 10/3/23. So that's how we can format dates, and unfortunately, the current release of FreeMarker does not support the classes in java.time package. And this package was introduced in Java 8, and classes like local date, one, uh, the one we are using here, and also local time, local date time, and so on are in that package. But fortunately, there is a project called FreeMarker Java 8, which adds support for Java time classes to FreeMarker. So this project is hosted on GitHub, and the README file contains basically the documentation and so on. So adding this to our project is pretty simple. So we just need to add a dependency and add a property to the project. So the dependency is this. So let's copy this one, and let me stop the project and go to pom.xml, and dependencies are here. So let's add that one here. Okay, so what did I do? Did I click save as? Anyway, I think it's saved. Let me see. Okay, so it shows FreeMarker Java 8 here. I think it's saved. Okay, and now that we have added the dependency, and there's one more thing to do. We need to add a config property to the project, and that config property is this one. So copy this one and put it under application.properties. That's under the source main resources folder. So put it here. And the property is pretty long. We don't exactly need to know all the details. Basically, it adds a wrapper around those time classes so that we can uh, format them in a certain way. Now, there's one thing that's a little bit tricky, and we need to be careful is this version. So this version 2.3.31 should match the version of FreeMarker in our project. And if this doesn't match, we will run into problems. So what exactly the FreeMarker version we are using? This is something we can find out from pom.xml. So open pom.xml and go to dependency hierarchy. Yeah, go to dependency hierarchy. On the right hand side, it shows all the resolved dependencies. Look for FreeMarker, which is here. Notice that our FreeMarker version is actually 2.3.32. That means we need to change this one to 32. Okay, so if we do that, then everything should work, and we can then use the format method, and this format as method will allow us to format it in a certain predefined way, like long date, medium date, short date. It will also allow us to format it using patterns like this. So let's run this thing again, and let's see. And go back here, refresh. Okay, something's not quite working. Let's do a project clean. Where is project clean? I think it's here. Clean project, and let's clean this project. And let's run this again. Okay, so now we have the default format of a local date, which is this one. And if we go in here and we say date format, let's do a long date or short date. Let's do a long date. And here it uses single quotes, but we can use double quotes as well. Because in FreeMarker, single quotes and double quotes are all fine. And so long date would look like this. And so let's suppose we want to format it in the pattern that's shown in our lab assignments. And that means, where are we? That means we can do a pattern like D, Y, 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 Y. And it shows October 7th, 2023. Okay, so that is it about all the important things about FreeMarker. Like I said before, all in all, it's a it's a good template engine to use. It works out of the box with Spring Boot. It's fast, and more importantly, it's pretty easy to learn. Just by knowing some basics, we can be quite productive with it. Okay, that is for today. Thank you, and see you next time.